I'm audible?
Yes, sir.
So please don't make noise. Please unmute. Please unmute.
All participants connecting online, kindly unmute your mic.
So disease is another issue, as you maybe have heard in the shrimp culture. In the shrimp culture, a lot of disease has created problems. Like you maybe have heard about the WSSV. You maybe have the whitetail diseases. So disease is also the constraints which hinders the growth in aquaculture. We need to have good disease management, good disease diagnostic things. Another thing which is important with respect to Indian aquaculture or global aquaculture, that's a vertical expansion. We have very limited species. If you look at China, China has more than 100 species in the aquaculture, in the culture practices. But in India, there are hardly 5 or 10 or 6 species which we are culturing. So we need to have the more culture fishes. We need to have the more biodiversity in terms of aquaculture, culture in the fishes. So that is also another constraint which aquaculture is not growing in a very well. Post-harvest issues are there. We are harvesting the things. We don't have the proper storage. We don't have the proper post-harvest management things, so that we can control the losses which we are harvesting. So a lot of climate change is another issue that creates problem nowadays everywhere. Your conference is on that topic only. So a lot of, as you know, the global warming, the seas are level is rising, a lot of fish are dying, temperature regulations are changing. So these are the challenges, these are the things which are big challenges for the aquaculture or the fisheries sector. But nevertheless, we have various platforms, various methods, various technologies are nowadays available which we can tackle, we can use to enhance the production of the aquaculture. Like you may be heard about the genome editing in the fishes. Also in the aquaculture, we are using genome editing methods to enhance the production in the aquaculture. Another is the competition biology, and we have the other techniques which are purely in the aquaculture based, like restorative system, like bioflux system, like kale culture. By using these technologies, we can enhance the production. But today's topic, today's thing, and another approach which we have presently today, that's the nanotechnology and the nanoscience. That's what our presentation was today. My topic was today to talk about what are the applications and what are the prospects for this nanotechnology and nanoscience for the aquaculture. So when we look at the nanotechnology, okay, as a name itself indicates, it's a nano, something small, and the technology intervention. So as per the US National Institute of Nanotechnology, they have defined this nanoscience or nanotechnology. These particles which are in the size range of between 1 to 100 nanometers. Okay, you have different types of particles. You have microparticles, you have higher than that. But the particles which are in the size of 1 to 100 nanometers, we call them nanoparticles. Okay, because these nanoparticles at the lower size have different properties. They doesn't have the same properties what the major or microns or millimeters size particles have. They have tremendous properties when the size is reduced. As you have seen, particularly in the engineering side nowadays, revolution has been created by this nanotechnology. You have small chips which have the capacity of 120 GB, which have small laptops are coming up, small things are electronics are coming. It is due to nanotechnology which has created this revolution in the engineering side, and same in the biological science also, and in aquaculture also we have used this nanotechnology. Term was coined in 1974 by one of the scientists. He is from Japan, which he has used this nanotechnology term. So if we talk about the revolution, what the earlier revolutions has been started, as you know, the industrial revolution starts in 1700. Then the industrial revolution started, people start electrifications. Then the IT revolution starts, information technology, this computer science and internet things has come. But now the fourth revolution, which is presently going on, it is with respect to nanotechnology. Everything is connected with the nanoscience. Everything is faster, whether it's a 2G spectrum, whether it's a 5G spectrum. But it is due to nanotechnology. It is a thinner, it is a faster, it's more practical. So what nowadays people are talking about, it's all about the nano size, it's all about the nanotechnology, which is creating amazing results in the everywhere. So you can see the last growth rate of commercial products from last 2 decades or 1 decade. The growth of nano products has been increasing tremendously. It is upsurging like anything. But actually, the idea which nanotechnology has been given, it's the credit goes to Dr. Feynman. Okay, as you know, he's a quantum physicist. He's a well-known scientist in the quantum physics. At that time, during the 70s and 80s centuries, he told, there are a plenty of rooms at the bottom level, at the atomic level, where we have different kinds of effects, where we have different kinds of properties. If we use that properties, those characteristics of the atoms, or those characteristics of forces, if we use for our practical life, for our device development, for our other purposes, it will create the miracle. So it was Dr. Feynman who has first find out, no, there are a lot of things at the bottom level which if we utilize in the proper way, we will create the miracles. So if we look inside us or outside our system, you see there are different types of atoms, there are different types of molecules which are already in the nano size. If you look our DNA, okay, which is known as the blueprint, it is 200 nanometer, 2 nanometer diameter, that's 20 angstrom. If you see the hydrogen atom, or you see the proteins, okay, biological molecules, yeah, these dendrimers, which are the form of this carbons. You see the virus has the size of 75 to 100 nanometers only. So most of the particles, most of the things which are working in this nature, which are mainly responsible for doing the functions in our biological system, they are already in the nano size. So what we are doing, using these properties, how these small sizes have more uptake of interstellar uptake, or this more absorption, we want to use that properties in the biological system, so that we have more production, and we will come up some good products for our utilizations. So but actually when we reduce the size, there are some properties which are important, which play the important role for these nanoparticles or nano sizes. Like you have here some catalytic property, you have magnetic property. It is from the engineering background, but if you look in the biological side, the properties, by reducing the size, by bringing the particles, by bringing the drug, by bringing something at the nano size, it increases permeability in our cell membranes. Okay, it enhances its permeability. Okay, it enhances its bioavailability in our system. It can easily cross blood barriers. So when we are making the nano size, it is easily absorbed. It's easily absorbed in our biological system as compared to when we have the large sizes. It has more surface volume ratios. That's why by these property, whether the mechanical, whether it's optical properties, whether it's a biological property, people are interested in these nanoparticles, or people are interested in the nanotechnology. So this is the significance what people have find out now. When we have done the work, people have done the work, they find out 100 nanometer size nanoparticles are absorbed 2.5 times greater than as compared to 1 micrometer sizes. So that means this property is great. It's near about 2 times more absorption is taking place of the particles as compared to the larger size. So this by using this application, we can deliver the drugs, we can deliver the vaccines, we can deliver some other things in the biological system in order to increase its bioavailability in the system, in order to have the more effects, in order to have the less toxic effect. If we deliver the higher size of the particles, it may have a more toxic effect as compared to if we use the small size particles, may have this toxic effect. So that's why the people are interested in the nano science and nano particles. In front of you, there is a figure, the inorganic. Okay, inorganic means there are the particles you have heard, silver nanoparticles, there are copper, there are iron particles, there are selenium nanoparticles. They all are coming out in the category of the inorganic nanoparticles. But there are also the polymeric nanoparticles, means those particles which is made from the polymers. Like well-known example is the chitosan, well-known example is the sodium alginate. Okay, these are the biodegradable particles. Yeah, you may have heard about this liposomes as dendrimers I was taking. They are the forms of the carbon or carbon nanotubes. Okay, there are various nanoparticles which we can synthesize in the laboratory, or which are already available with the commercial companies. You can purchase them, you can use them as per your experiment needs, as per your research work, you can use them. So, but every particle has its own advantage and disadvantage. As this science has been evolved from last 20 years more, people have concern issues with respect to, particularly with respect to this inorganic nanoparticles, with respect to genotoxicity or with respect to the toxicity. So you have to be careful while choosing this nanoparticles which you want to use. So if we talk about the classification of the nanoparticles, there may be some natural polymers like proteins are there, rubber is there, chitosan I talk, semi-synthetic polymers are there, rayon is there. Okay, synthetic polymers are there, polyethylene, like we have the polythene also, they are the polymers. So it is up to us which one we want to use. But yes, But while selecting the nanoparticle, while selecting the particle, you have to take the care. These particles can be easily synthesized. They should be have easy to synthesize method. There should not be the complicated method. It should be easily characterized. So after you synthesize the particles, you need to characterize it. You need to find out what is its size. As we are defining these nanoparticles, it is a size between 100 nanometers. If it is a large size, you have to reduce its size. You have to check its characterization by using a nano analyzer, by using the scanning electron microscope, or by using this some other methods which you can find out the size. And its charge is also important. What is its charge? The property is known as the zeta potential. By using this zeta potential property, you can find out whether the particles are stable or not, and other things which you need to know when particularly you are using for this biological system. It should be the biodegradable. Okay, it should not be non-biodegradable. If it should be biodegradable. It should not accumulate inside the body. It should be easily biodegradable. It should be biocompatible also. Okay, it should not get any harm with our cellular organs. It should be biocompatible with our biological system. Yeah, it should be non-toxic. It should be inexpensive. So while selecting any type of nanoparticles, whether you are going for the organic or inorganic, you have to take care of these properties. You have to take care of these criteria which are necessary for us. So coming to the main topic which was today assigned to me, I have in this slide, I have in the nutshell, I have bring this slide where you can see carefully what is the this utilization, or what is the application of nanotechnology in the fisheries side or in aquaculture side, whether it's the water filtration remediation. Okay, there are a lot of products available in the market where the nanoparticles are there, or nanotechnology has been by using the filter, by using these nano checks, by using these nano products. You can have easily purification of water. There are the smart drug delivery of nano vaccines. There are nano vaccines where we are using this. We have also done a little bit of work about the nano vaccines. Feed nutraceuticals. We want to deliver nutraceuticals, small feed ingredients by using this nano. It is a very good application of nanotechnology where we can increase the biodegradability of gene. Okay, as you know, okay, this gene delivery is also using we nano encapsulate plasmid or gene in some polymers, or conjugate with some particles, so that we can easily deliver inside this. Another application which nowadays is revolutionized, that's this nanopore sequencing. It's a DNA sequencing and just sequence new one. The size of this nanopore sequencing is just like a pen drive. It's a small like pen drive. If you have heard about this NGS technology, we have Almuna, we have some other platforms available. But this nanopore sequencing, in which nanotechnology has been incorporated, is a very small nano size instrument, like this pen drive. So where we can do the sequencing of any fish genome or any genome. So this is our work. What we have worked on the nanotechnology. Our team has done a lot of work. We have published a lot of work also with respect to nanotechnology. It was the first work that has been published in India with respect to nanotechnology and aquaculture. What we have done here, we have conjugated this luteinizing hormone, releasing hormone, LH-RH hormone, with chitosan. Chitosan, it's itself a powder form product. It's a product of the fisheries. It is known as millennium product. It has its application are remarkable. It's known as millennium products. Okay, this is a polymer. Okay, it's made from chitin. This polymer, this chitosan, we have made the nanoparticle of chitin. We have first to reduce it. Then we have conjugate hormones, LH-RH, luteinizing hormone. Our objective was to increase the reproductive output of fish. Okay, our was to increase the egg release, to see what will happen to the hormone profile. Okay, we have conjugated this, and we have used this organic polymer, this chitosan, and we have used inorganic nanoparticle also. That's a golden nanoparticles. Also, we have incorporated with this LH-RH to find out what will happen to the fish during the breeding time, or what will happen to reproductive output. So these are the in front of you. It is a figure. It is a figure of with a different concentration of chitosan and the golden nanoparticles, and in that we have put LH-RH hormone to see the effect. Actually, the mechanism was this. This was a hypothetical that we was predicting. As you know, the chitosan, it's a cationic in nature. Okay, it's cationic. It has a positive charge, and we can easily bind it with the DNA or with the hormones which has a negatively charged. We have by magnetic style at the 60 degree with temperature. We have entrapped it or encapsulated it hormones. You can see that clearly. Here it's conjugated with the chitosan particles. Then we ejected with the fish, but before ejecting the fish, we have characterized, we was doubt to find out whether the size of the particles is at the nano size or not. You can see this is the diagram from the nano analyzer. It gives the spectrum. It gives the like normal distribution. It gives distribution of these particles. You can see here it will give the data whether your particles 50%, how much are the size, 80%, how much are the size. It will give average also. So you have to before using the nano particles, after you have developed, built, you have synthesized it in the laboratory, you have to characterize it. You have to find out what is actually size, whether they are in the nano size or not. And this figure is the scanning electron microscope figure, these small particles you are currently seeing. So after injecting the fish, this chitosan LHRH conjugated particles and the gold nanoparticles with LHRH, we have find out the serum hormones, whether it's LH, FSH, or hormones from different time interval. We was interested to see what will happen, because when we are encapsulated something, we was predicted no, it will protect it from the inside enzymes, which where the proteases are present, where the DNases are present inside, because we want to enhance the bioavailability. We was interested to see how much surge, how much increase this hormone profile will remain. Here you can see with respect to control, with respect to treatment, hormones sustain or hormone upsurge is continuously going on. That was the results for the marvelous. So we was what our hypothesis was there. It was absolutely going the right way. But after breeding the fish, we was concerned to see the reproductive output, whether with respect to the relative fertilization acts, with respect to the fertilization aid. It was more with respect to our treatments. What treatments our we have decided are with respect to the control. The reproductive output was also great. It was near about 70 to 80%. This fertilization rate was there. Eggs was more as compared to this. So we was also interested to have this actually histopathology to see what happened to the ovary with respect to control. You can see with respect to different treatments. You can see the this ovary has been unspended. They have released the eggs. That's why the holes are here in some treatments. It's clearly shown. So everything was working good. So we have then again checking some other fishes, and from my work, it was my master's work that I have done in the Central Institute of Fisheries, Mumbai. So later on, we have patented this formulation, and we have got patents from the Indian government. So another work that we have worked in this, we was interested to have, there's one gene, one protein which is called a kispeptin gene. Okay, it's a protein which is responsible for the release of hormones. It's about the hypothalamus. It controls all the release of factors. And this hypothalamus, after hypothalamus, it which enhance which sends the signal to the pituitary to release other hormones. But actually, this kispeptin is the main neurocrine which influences, which stimulates hypothalamus to release the hormones. So we have done first the molecular characterization. Then after done the molecular characterization, we have found there are
and sustainability. Thank you, sir. Moving on further on our schedule, we have our next participant in category of Senior Scientist Award, Dr. Vineet Kumar. Dr. Vineet Kumar is an associate professor in the School of Bioengineering and Biosciences, Lovely Professional University, Fagwara. We welcome you, sir. Dr. Vineet Kumar. आप हमको दोबारा बोल कुमार no issues, sir. So you may start.
Yes, is I am audible? Yes. Hello. 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 I'm sorry. I'm sorry. There was some light issue here. Is I am audible?
Yes, sir.
Is my presentation is audible? Yes, is presentation is visible? Presentation is visible? Yes.
Sir, actually the presentation of Dr. Vineet Kumar is going on.
Okay. 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 Okay.
You have to join later, please,
Okay.
after this presentation. You may join. Dr. Vineet Kumar.
चलो क्या
Am I audible?
Dr. Vineet Kumar.
Am I audible?
Okay. Yes,
Am I
sir,
audible?
we can hear you now.
A very good morning.
Dr. Vineet, you may start your presentation, please.
Please, let me. is it visible?
Yes, sir. The screen is visible.
All right. Very good morning to all of you. Can I proceed with the presentation?
Yes, sir.
Very good morning. I'm going to talk on nanotechnology, a possible solution for environmental and climate change problems. I thank the organizer for giving me opportunity to present this topic. So climate change, as in previous few decades, we have a lot of environmental concern, global concerns. So as we can see, last 2 decades, they have been some of the hottest days or uh, time interval in 400-year history. So average Earth temperature is going average average temperature is going to rise by 1.4 degree. So since 8080, we are observing some change in the temperature. So it is expected to grow at higher rate as the time progress, and we can see uh, we have been trying hard to reduce this rise in the temperature, and it is expected to rise toward the end of 21st century at a very high rate, so that we may not be able to sustain. So why is it trouble? Because we all know it lead to global warming. Primary and secondary pollutant are released. Glacier melting, we all know, it would lead to more and more rise in the groundwater level. Sea level, it would rise. A coastal erosion of soil would occur, and we would have more and more infectious disease as a result. Because glacier also contain a large number of the microorganisms.
Right, no, not moving.
Sorry.
The screen is showing first slide only.
Is it moving now?
No, sir.
Okay, I guess there is some problem with the full screen. Is it moving now?
Yes, sir.
Can I keep at this as such? Is it visible clearly?
Yes,
So these are a few greenhouse gases: carbon dioxide, methane, nitrous oxide, water vapors, ozone. So these two greenhouse effect, we have few human industrial processes, human activities in place. So carbon dioxide, one of the major contributor, we all know, it lead to uh, it is a greenhouse gas. It is present in the Earth atmosphere at a low concentration, but more and more it is going to rise. Um, major contributor are fossil fuels, and since industrial evolution, we can observe that there is around 40% rise in the CO2 level. And this graph shows how over a period of time it is increasing. And now it is increasing very drastically with more and more industrial and uh, vehicle pollution we do have in place. So again, this slide show world scenario, how different countries they are contributing to CO2 emission. So majority we have developing as well as developed country major contributor to the CO2 emission. This slide show how if we control, if we have no climate change policy, we would have a very high rise in the temperature, approximately 4 to 4.8. So if we stick to the current policies, it could be managed up to 2.7 to 3.1. And if we stick to the pledge and targets of 2.4 degrees centigrade could be maintained. And we need to follow very stringent the bottom two lines. If we have to stick to, or we have to contain it to 1.5 degree. So there are different pathways already available at the global level. And if follow these pathways, this slide show if we have to follow these pathways that contain remedial measure to contain it up to 1.5 degrees centigrade. So we could be able to reduce it drastically by 2040 or around 2030, 2040. However, it is quite very difficult to follow because we all know economies and pollution, there is some correlation between them. The greener solution, they are currently very costly and not so cost effective. So that's why even a global consensus on sticking to even 2 degrees centigrade pathway. So still it could be manageable. So different countries, they are trying at their own level. And this slide show how electricity demand. It is one. It is also one of the major contributor. We all know most of the electronic things, even nowadays transportation. So we have increase in the demand of the electricity. This show how over a period of time, different reason, India and China, because of population, they have higher electricity demand. And we have to depend upon non-renewable resources, coal and various petrochemicals to have electricity. Because hydroelectricity and solar, we are not able to tap up to the maximum level. So this is a kind of data that show power plant, they contribute mostly to the, this is 2022 emission data. So majorly it is power plant that are contributing. Along with that, we have oil and gas consumption and other chemicals, refineries, even minerals, water, purification and all those processes. It contribute toward the emission. And we can see because of such pollutant, we have mostly contribution of greenhouse gases, majorly CO2 and methane and other gases. So this slide show how total power generation is increasing because of increase in the demand. And majorly we can see on the right side, it is majorly we have to depend upon the non-fossil fuels, the fossil fuel mostly, and non-fossil fuels also we are trying, but the contribution is not that much. We are not able to make it to the maximum. So along with that, we have animal feed, food, animal-based food product, agriculture as a contributor. Particularly the animal-based food product, they contribute a lot toward the CO2 emission. So that's why, because large amount of CO2 is released. First thing is the agriculture produce, they are converted by animal to methane. So that lead to some extra CO2 emission. So meat production, particularly meat-based diet, has to be replaced with some of the vegan food or some kind of the vegetarian-based food product that tastes like animal food. Animal diet is constituted by maize, soybean, wheat, alfalfa, rice. These are the major crops that are grown to feed the animals. That ultimately lead to greenhouse gas emission. Around 11% of global greenhouse gas emission is contributed by it. So alternative may be so well-managed grazing of cattle or grassland may be done rather than, because these grassland are not utilized and the agriculture land is in addition used for animal feed. So that's why it could be managed in a better sense. So as well as soil health could be improved by using some kind of the proper crop cover. So certain ingredient they can be incorporated in coffee to reduce, because cows they contribute, cattle they contribute to CO2 as well as methane, mainly methane emission they contribute, that lead to greenhouse effect. So this is a how the feed system is interrelated with the food value chain, and ultimately lead to emission of the uh, greenhouse gases. So majorly it is swine and poultry layers, beef, dairy, cattle, they contribute a lot toward the, so data is in million metric ton. So basically it is beef, dairy, cattle that contribute most commonly around 80%. So we can replace at least non-vegetarian, among non-vegetarian also beef and dairy cattle, we can replace them with the poultry or some of the uh, egg, poultry, or some another swine-based food product, then it would be an alternative. So this is, you all know, Costco 200 nation, they try to stick to 1.5-degree goal of Paris Agreement. So a different other country, including India, is party to it. Decided to put carbon market. We all know carbon credit nowadays is a reality, and it is being traded at global level. So COP, that is 27, it also has same goal. In addition, it keep the 1.5 goal alive, and it put onus on the private sector as well as youth, observers, civil society, and everyone. So as well as it focus on generation greed. So, how nanotechnology may be useful? Nanotechnology, we all know, it is a kind of it is a field that utilizes nanomaterials. Nanomaterials are the materials that have at least one dimension in the nanometer range. So basically, the material property changes drastically, just like gold. It is inert. However, if we convert even gold into nanomaterials, so it turn out to be a good catalyst. So that's why we can utilize nanotechnology or nanomaterial to improvise the existing technology. So I'm not going into brief historical colorful because of the nanomaterials. Damascus sword, it contained carbon nanotubes. So around 1910, although earlier it was not known, 1910 the term nanometer came. So it was father of nanotechnology, Richard Feynman, who was given very basic uh, presentation. There is a plenty of room at the bottom. Means you will be able to uh, 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 utilize or engineer thing at the molecular level. And nowadays we all know we can engineer that. So and it is a reality. It was basically an Taniguchi who has given the term nanotechnology. And first atom scenes nanomaterial initially in 1981. Winning and Rohr, they got Nobel Prize for this. And another eminent contributor is Richard Exler. 1986, he has written very able to manipulate things at the molecular level. So this slide show how if we have change in the surface area. If we have smaller thing, the surface area increases drastically. So as we increase the diameter of a particle, so we have a decrease in the surface atom. So here we can see how bulk atom, as the particle size increases, we have more and more of the sorry, if we decrease the particle size, we have more and more surface atom, and if we increase the diameter, we have more the bulk atom. So basically, because this is because of the surface area concept, same thing, and we have change in the melting temperature as well as. So a magnetic property, super paramagnetic material, we can see basically a kind of material that become magnetized once placed in magnetic field, and once we remove them, they become non-magnetic. So it is very useful for biological property. As well as we can change the conductance behavior of the material. So that is very useful in various electronic devices that has been used, including engines, electronic things that could increase the efficiency of the existing materials. Thus, less electricity would be utilized, less coal we have to burn to generate that electricity, and we will have less of the environmental pollution. So we can see even semiconductor, if we change the size 50 nanometer and 10 nanometer, so there will be difference in the band gap, that is the ground state to higher energy state balance. So there are two kind of nanomaterials, natural and man-made nanomaterials. These are few examples. Peacock feather, it contains naturally nanomaterials. Lotus, it is hydrophobic because of the some nanostructure there. Virus is already in that range. And this is SEM image of how these peacock feather, they appear in the scanning electron microscope. The right side we have this SEM image of the lotus leaf. So there are different ways to synthesize nanomaterial. It could be top-down approach, that is breaking larger thing into smaller things. There are different methods, and we can synthesize various type of nanomaterial, right from metal oxide, polymeric. Like bottom up means we use chemical, we react them to make the nanomaterials. So there are different methods in pyrolysis, chemical vapor synthesis, spinning, salt gel, thermal decomposition. So this is how very first nanomaterial was, the structure was given, carbon 60, also known as buckyballs or fullers, after the engineer. So the protocol and Smalley, they got Nobel Prize. They were not able to have structure of this. They have taken inspiration from some dome-shaped biosphere they have seen while visiting in Montreal, some of these structures. From there, they have an idea. That's why they name it after the engineer, Richard Buckminster Fuller. So this structure is also known as fullerenes nowadays. There are different types of the nanostructure, zero dimension, just like quantum dots, or one dimension nanovars, nanotubes, fibers, two-dimension nanoplates, graphene sheet, we have their nanomaterials, and three-dimensional, just like graphene foams, also used to absorb some of the pollutant, and nano container for drug delivery application. So in different shapes they can be designed, and inorganic, organic, we can functionalize their surface with different kind of the things, and we can have any application from plant production, livestock, animal, veterinary use, food processing, food packaging, and disease diagnosis to disease. So this slide show how green synthesis is better than we have a degradable product, atomic economy. So all the green chemistry principle it follows. These are the green chemistry principle, green nanotechnology follows. And we can have a different method in this solvothermal synthesis, microwave, electrochemical, that can be used to have a greener synthesis. And so green chemistry and nanotechnology ultimately lead to sustainable, safe, eco-friendly, and cost-effective synthesis. It uses non-solvent, non-toxic solvents. Pharmaceuticals industry, it is very useful. We can have novel catalysts, cosmetic, other in vivo applications. So briefly, I will talk about solution to global warming. These are the 5 possible solutions where nanotechnology can be useful. First, we will be able to minimize the greenhouse gas emission by utilizing nanotechnology. We should increase the efficiency of the current things as a solution we can provide. And we can decrease overall energy consumption as the material electronic devices that contain nanomaterial, just like 3 nanometer chip, 5 nanometer, 7 nanometer, it is a reality now. So we can decrease the energy consumption, we can increase the existing technology, we can coat their surface to minimize the energy loss or make them more functional. As well as we can use renewable energy resources to generate nanomaterials, and we can have better carbon management. Convert the CO2 in the environment into some useful product. There are some technologies already available, and we can increase the forest cover already RET. Plus, it's reducing emissions from deforestation and forest degradation that is in place that focus over increasing the green cover. And we all know carbon credit, it is also helping countries to have better cover so that they can have even benefit in term of their economies. So few what we call as incidents some people very first very least known. It was around 1730 Jodhpur 363 Bishnoi, they died for green tea. Yes, so Amrita Devi Bishnoi was the leader. Some incidents where the gents, the male, they were befooled. They were called to some another place. Still, the ladies they defended the trees, and the ladies they died to save the tree. Second one, we all know very famous Chipko Andolan that we call as movement, 1974. We can minimize the greenhouse gas emission by reducing meat and dairy consumption, by promoting low carbon meat or dairy product, as well as vegetarian based vegan based diets. A few heme based products they are already in market, as well as reducing the food wastage so that less vegetative part produces more seeds, and we have less agriculture residue. We can have by reducing the devices available that can be placed at the mouth of the cows or cattle that could reduce the methane emission. And we can have lab grown food product, just an alternative to the animal food product. Already hydrogen ships they are in place. Older 2006, this is a picture of how electrolysis of water can be used to fuel electric planes. So we can have increase the performance of the existing technology using the nanomaterials. We can have better CO2 absorption using nanomaterials. We can have fast adoption, high CO2 selectivity to remove CO2 from the environment, high recyclability of the product so that they themselves do not generate a lot of waste at the end of the day. So that's why it could be done in a better way. I'm not going into too much detail of it because of time constraint. And we can decrease the energy consumption. Few things are carbon fighting cloth dryers that can be used to reduce the dryer or washing machine consumption, magnetic refrigerators, advanced window control where shades can be adjusted according to the season, environmental condition and requirement inside summer and winter. And next generation insulations over the wall, over the roof, reflective roofing materials just to absorb or reflect depending upon the environment, and brighter LEDs, better lighting can be done. This slide show how current technology, just 3 to 4 nanometer nano car, it is around 4 fullerenes sweep. So between 170 degrees centigrade to 225 degrees centigrade, it can move. So means we can minimize the tools that we have. It could be of multiple use. We can have smaller and smaller devices. So although this technology is at very nascent phase, and this is how the current efficiency is. So we have from primary source 100%, it reaches, if we have to use for water heating, it reaches around 23-24%. So we have too much energy loss in between. If we can use nanotechnology, we could reduce it. This is how we can use renewable resources. Biofuel production is increasing over a period of time. So 2022, the decrease is because of the COVID, and now it has again increased. So few renewable energy resources, geothermal, tidal, wind, solar, all these existing thing can be improved by, for example, in some areas, wind, we could have a turbines, lighter, better efficiency they convert. Hydro also, we have a kind of electronic things that could utilize uh, uh, the material in better sense. Just like in geothermal, we could have a nanostructure hard layer system to have geothermal drill probes that could withstand high pressure. So solar energy, we could have anti-reflective nano coating in place. In case of thermoelectronic, we can have a kind of material we have discussed